This question came in GTA, and also it was actually it's the original question from AIME. So let's try. It's a difficult question, not easy question. So first we have to understand the language of the question. It's a lengthy also. So do you understand, Karunish, what is asking here? AN be the ratio of shots made to shots attempted after n shots.
On the probability that it's a success.
Probability of success is, with success of basketball has a constant probability P. So let's say P the probability of making a shot, correct?
Yes, sir.
Making a shot means putting the basket in the, like ball in the
Yes.
basket. Probability of making a shot. And that probability is given 0.4. And Q is, this is S is success and N is no success. I'm calling it like this, P of S and P of N. Or S dash, whatever. But I don't want to use the complement bar sign. It's okay. And Q is probability of no success. So I don't want to write the 0.6. Now this so far so good, but the problem starts from here. What is the meaning of AN? AN is a number with the ratio of the shots made to shots attempted after n shots. Can you just explain what is the meaning? If you can interpret it.
Number of shots attempted would be the total number of attempts, sir. So basically the sample space. And shots made would be the success, number of successes.
So what is the meaning of AN?
AN would be the probability that a shot is a success.
Not the probability, please understand. They are saying that AN be the ratio of shots made
Yes, sir.
to shots attempted. How many attempted shots? N shots. So suppose you are attempting 3 shots. You understood my point?
Yes, sir.
Suppose you attempted 3 shots and you have made only 1 shot. So this A3 will become 1 by 3, correct?
Yes, sir.
You are throwing 3 times the ball in the basket and you have made only 1 time the success. It means that time the A3 will become 1 by 3. So in one language you can say, in one's actually understanding we can say it's a probability. But when you are making, let's say 4 attempts. So after 4 attempts, let's say you have made 2 shots or 2 successes. So what will become A4 then?
2 by 4 should be 1 by 2, sir.
So 1 by 2. Understood? Yes. So far no
Yes,
problem.
sir.
Now just tell me what is the meaning of A10?
10 total attempts.
Huh?
10 total attempts, sir.
Total not outcomes. You should say attempts. Out
Yes,
of
sir.
10 attempts,
sir.
And this is A10, and how many successes he has got, I don't know. So let's say he has made X shots. Correct?
Yes, sir.
So X is the number of successes. Correct? So can you tell us what is this A10 given is 0.4? And so this is X by 10. It means we get X is equal to 4. Correct or not?
Yes, sir.
Now this is clear now that out of 10 attempts, after 10 attempts, so I should say out of 10 attempts, the American language is a little bit, maybe not that difficult, but it's a different to understand. The out of 10 shots or after 10 shots, the player must have 4 shots, must have 4 successes, correct or not?
Yes, sir.
This is the meaning of 810 is equal to 0.4. So this thing is confirmed that we need 4 successes out of 10 shots.
Of 10 shots. Yes, sir.
Correct. Now the question is saying the probability that A10 is 0.4, we cracked it, and AN is lesser than equal to 0.4 for all n such that 1 to 9 is this one. What is the meaning of this and this?
AN plus 1. For any number of shots between 1 and 9,
Very good.
the ratio of successes to attempts should be less than 0.4.
Very good. Exactly. Very good. And means that suppose you are you actually cracked it. So suppose you are making one attempt. Okay, so let's jot it down. So suppose you are making one attempt. So let's say the attempt number 1. So let's say attempt
It
number
has
1.
to be a failure, sir.
It has to be failure. Why?
Because out of 1, we have only 2 outcomes. Either it's a success or a failure. And if it's a success, it will be 1 by 1, which is greater than 0.4. So it needs to be less than 0.4.
Yes. We can say like this also. Like suppose you are making one attempt and 1 is a success, then will become 1. And
Yes,
that
sir.
is always greater than
0.4. So it has to be 0. Sir.
It had to be 0. Very good. Very good. Very good. So that is actually very clear that A1 how do we write? Attempt number 1 should be 0. So let's you understood? Okay, so that should be failure. Let's be writing, we are writing the string. So how do we write the failure? Or let's say no success. N and S I've written. Let's say no success here. Then what about the second one?
The second one also has to be a failure, sir. Since
Why?
1 by 2 is greater than 0.
Exactly. Very good. Exactly. Very good. No success. Then
the third one, it can be a success or a failure, sir.
Yeah, third one can be success. Fourth one. So let's focus on success first. So third one can be success or not? Yes, it can be. So third can be success. Fourth one can be success or not?
No, sir. It has to be a failure, sir.
Successes where? It can be at third,
3 or 4.
4. It can be possible or not? Suppose I'm saying 4 and I'm getting, let's say, 2 successes before that. So it'll become 1 by 2.
Yes, sir.
And suppose I'm getting 1 success then?
Then it will be less than 0.4, sir.
So it is possible or not?
No, sir. It has to be a failure, sir. If there's at least 1 success before 4.
No. Before 1 success, the 1 success can be possible or not?
Yes.
Hmm?
1 success
Okay.
before 4.
So we can say in this way, like, yeah, let's say the first success we got at 3. First success we got. So let's say first success or first time success. First success at 3, at third position we can get or not?
Yes, sir.
Suppose I'm saying the first success at 4. It is possible or not now?
Yes, sir. Now it's possible, sir.
Now it's possible now. So let's decide in this way. So first success at 4th position possible. First success at 5th position possible or not?
Yes, sir.
6th position?
Yes,
6th. Yes, because every time first you are getting, so 1 by 6 will come, correct?
7th also possible, sir.
7 also possible. Now tell me 8 is possible or not?
But 8 won't be possible, sir. We
Right.
need at least 4 total successes.
Exactly, very good.
For 8.
So if you take 8, 9, 10, so I need 1 more, na? That's why I need 4.
Yes, sir.
Correct? Exactly.
Yes,
Smart. It means I have only these many attempts I have to make. Means this is the first. This is the number of attempts at which the position of attempts at which the first success is going to happen. Now, in all these cases, we have to find out what are the possible case, means what are the possible things. So let's say I'm taking at let's call it this attempt number AI. So let's call it like A, and I is the index. How do we write it? A, and it depends upon I, and I are the values listed. So A3 means the first attempt is happening at 3. Correct. So what are the possible cases? How can we write? So of course the first attempt is N, second
will
attempt
be
is N.
failures.
Then
Third will be a success.
Then
fourth has to be a failure.
Fourth has to be failure. Very good.
Fifth can be success or
okay, very good. So yes, so we have to make the cases now. So let's say at the first time is getting success. Then
sixth, it has to be a failure.
Sixth has to be failure. So N. Then
seventh can be success.
Seventh can be success or cannot be success also, no?
Yes,
okay,
sir.
So let's take first success. Then
eighth has to be a failure.
Yes. Ninth has to be failure. Why? Because you see that they are saying that 810 is 0.4. Means it has to be like it has to be at the last position. It must be successful. Otherwise, yes. the 4 successes will the 4 success will cannot go below, or the 4 success cannot go out also, na, after 10. Correct?
Yes, sir.
So it had to be success. Now realize that a string is happening. That these are the values we are changing, but this S and N are fixed always.
Yes.
In this case, yes or no?
Yes, sir.
Yes. So can you find out what are the number of possible cases in this? Like this you took. So again you write N. And success is there also. By the way, this is also in this case, S is also not changed. This all are fixed, and here also fixed. Now the problem is that unlike to our usual probability question, we can't just say that okay, this is factorial. Why? Because it depends where the S goes. It cannot come anywhere. Like, correct? You understand my point?
Yes, sir. Understood, sir.
So can you tell me other case? It can be again N here.
Yes, sir.
Then
again N maybe.
N we can write. Then S we can write or not?
Yes, sir.
Then N or S, I just fix it.
Yes, sir.
So this is fixed and this is fixed. So I'm not going to write these two. We are only changing this thing. So can you just count all those, please? Do you need a notebook? Take your time. In this
sir,
case,
could you scroll up, sir? I will write down from the beginning.
Okay. So question also. Can you suggest what the next one?
So, NNS.
NNS.
NNN.
NNN. Team. So 5 or 4 no, or S, correct? So this we don't actually count. We have to only count this. Okay. So only you have taken, I think, no, 2 S's should be there.
Yes, sir.
So we can say here N and S. Okay. Other?
NNNSSN.
NNNS.
S N.
NS, can you write?
Yes, sir. NS or SN.
So again, NNN, SSN. 1,
Yes,
2,
sir.
3, 4, 5. Other possibilities? Can you also write like this? N, 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 N,
S S S.
S, S. Can write?
Yes.
Yes. Next. Can we write NNS? NNS. We have already written. Sure. Can we write
Now we can start
NNN?
from NS now, sir.
Sorry?
Now we can start from NS now.
So NS, we have already taken here. NS1, yeah, one NS I think we can write because we have taken only one NS. So one NS I can write. And then already we have taken NSNN. So what we can take now? NSN, NNNS. No?
Yes, sir.
Excuse me. NSN, NSN, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 6, 1, 2, 3, 4, 5. One more is I can write here. NS NS and triple NS. Can I write NS triple N? I think it's possible. I think after that there are no such possibilities. So let's see, this is 7. Correct? 1, 2, 3,
Yes,
4,
sir.
5, 6, 7. What about A4? A4 is what?
First three will be N, sir.
First 3 will be N. So you see that I can simply swap these two, na? N and S. Sorry, these two. Hello.
Yes,
If I
sir.
can swap these two, N and S, then automatically all will be fulfilled.
Yes, sir.
No. And These three, and this is the fourth attempt, and after that everything will be consistent. What will happen, because I'm just shifting this here, so it will be SSS, and after that nobody will be there. So for that also we got 7. What about A5? So we start with because first 4 attempts would be N, correct?
Yes, sir.
So N, 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 N. So that we are not going to count. Then S. And this is going to be S. So 4 and 1, 5 we have already fixed. And we will see between them.
And last one should be it.
Last also S, na?
So only 4 are left, and out of those,
Yeah.
3 will be in S, sir. So 2 will be S, 2 will be in.
2 will be S and 2 will be N. So what we can write here? Tell me. First one, what we can write?
SN, SN.
I can write S, S,
SN, SN.
S, S, SN.
SN, SN, we can write.
SN, SN. We can write. S, N, S, N. Then we can write S, N, and S.
Yes.
No?
Yes, sir.
Then
NS, NS,
NS, NS. And then
NSSN.
NS, SN. Perfect. What about N and SS? Is possible or not? Check it. Yes.
Yes, sir.
I got. So I think after that is not possible. So 5. A6. N, 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 N. And S is also fixed. And here also S is fixed. I think now the number of it here 1, 2, 3, 4, 5, 6, and 7. So 3 only we need in between. So what we can write? I can write SSN first. Then what I can write, Cornish? SNS.
SNS and NSS.
NSS. So this is 3.
Yes, sir.
Correct. What about 7, the last one? I told you it's a very difficult question. So N, It's actually time taking. 1, 2, 3, 4, 5.
Only one possibility, sir.
Only one. Yes. So in this case, only one. Very good. So in total, we got 23 cases. In these 23 cases, now we have to find the probability in that form. Okay, so how many times we are getting the success? Number of successes, how many times in all these 4 attempts? Sorry, 10 attempts. How many successes we are getting? 4, na?
Yes, sir.
So success probability is 0.4, correct?
Yes, sir.
So 0.4 is happening 4 times, and 0.6 is happening 6 times. But this all happening is happening 23 times. Yes?
Yes, sir.
And that is equal to the structure given, that is what? PQR, P to the power A, Q to the power B and R divided by S to the power C. So we have to, and already said that ABC, sorry, PQR, what are the ABC are prime numbers? PQR and S are prime numbers, ABC are positive integers. So PQR is a prime number. So let me just write it in terms of the fraction. So what we get here, 23, and this is going to be, I think after that you can do it. So 2 by 5 now.
Yes, sir.
And this is going to be 3 by 5.
Sir,
Mm.
I got it as 23 into 2 to the power of 4 into 3 to the power of 6
Mm-hmm.
into, sorry, divided by 5 to the power of 10.
Mm. So we compare na, after this.
Yes, sir.
So we compare, then what we get? R value is 23. And P value, how can we decide that P and B? But anyway, see what they're asking. They're asking the A plus B
It's
plus is all the
cumulative anyways.
cumulative and also symmetric, na? So in the summation, so they know actually
Yes, sir.
whatever you take. So let's say P value is 2, so A value will become 4, and Q value is 3, so B value is 6, and S, the value of S is 5, and the value of C is 10. Now let's find it. They're asking PQRS and ABC ka product. So what the product? A plus B plus C. So we got 660. Okay.
Yes, sir.
Very good. Very good. You cracked it. Excellent. All right. So just give me 1 minute. I'm taking some water. Okay. Okay, Kronesh. All right. So suppose I give one question to you. You will do something different, and most probably, if my meeting is there, so at night also, if I'm free, then I will take one class. Okay.
Okay, sir.
At 9. All right. So be ready. I will inform the father. Suppose I'm taking one here. Oh, wait. What do you want to say? Okay. 1, 2, 3, 4, 5. 4 I need now. 1, 2, 3. Wait. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, tell me what is the grid size here I'm drawing? 6 by 4 I can say.
24 square inches.
24 squares. Okay. And if I ask you that someone is starting from here, the point A, and he wants to reach this point B. Okay. You remember I taught this in the class when you were there, permutation combination, if you remember. But if you forget, then again I will see. So let's say I am just taking that we are just moving in such a way from A to B so that we can again only move the right and the up. Okay, only we can move right and the up. Okay, then how many number of ways to start from A to and go to B? So I taught you one way that when we are moving right and up, whenever we are moving and ending the corner, we have to count that how many how many possible ways you reached from there. So the idea is that this is one, this is one, this is on the same horizontal line, one ways, because from here the number of ways to reach here is one, reach here is one, reach here is one, again number of ways here one. So on that the number of ways will be one only, one and one. And on this vertical line again the number of ways will be one only. So one,
Yes, sir.
one, correct? But when you reach the corner, if now you can recall, I think you have done this question in the class perhaps. So if this corner, what is the number of way to reach? Now 1 plus 1, that is 2. Because 1 we can move from here and 1 we can move from here. So number of ways to reach the corner will be 2. Now can you tell me what is the number of ways for this corner?
Which corner, sir?
This one, here, this corner.
4, sir.
No. What you do, whatever, so this corner is coming from here and here. So this was 2, this was 1. So this will become 3.
Yes.
I'll show you how. One way you can go like this. One way you can go like this. And one way you can go like this. Because you don't have to go down. You have to go only right and up. Correct or not? Now tell me, Kaunesh, what is the number of way here you get?
4, sir.
Okay, very good. What is the number of ways to get here?
5.
5. What is the number of ways to get here?
6, sir.
6. And here?
7.
7. But suppose I tell you that in such a way you have to move that you cannot go above this line. Means you cannot go by this route. Means you have to go below it only. And can you find? So let me just draw this line, then I will explain. So suppose I'm drawing this, I'm connecting directly A to B. Now how do we know that this corner is above it? Okay, so we'll just find out. So this point I can take 0, 0. And this point I can take because 6, 4, correct?
Yes, sir.
And 6, 4, so what is the equation of the line we can find? Y is equal to 6 by 4, that is 3 by 2x.
3 by 2x.
Correct?
Yes.
Okay. So now suppose you have to find out that this point, so this point is 1 comma 1. So 1 comma 1 is satisfying or not? What is the position? So let's say is equal to 0. So if you put 1 comma 1, it's
It's
coming what?
opposite.
It's above, it's positive, no? So it cannot be. Also,
Yes.
it's a grid is perfect, so this is also showing. It means now what we can do? How do you find them? What is the number of ways to reach there? Because this is not there now, the seed. We cannot take this step. So the number of ways to reach at this position, it will be changed now. Is it clear?
Yes, sir.
So tell me, what is the number of ways to reach there? Here.
1, sir.
Here there is only one way. Very good. This is 1. Then this will become 2. This is
3 and 5.
3, 4 and 5. Okay, this corner is actually exactly on this line. So this can be taken or not.
Yes,
Tell
sir.
me. Oh, no, it's below. We have to be below, na? How can we take? You cannot take, na? Or we can take.
No, sir. We can take.
Let's say I can take. So suppose I can take. So what we get here? 2. Because on this line, vertical line, there is no such intersection is coming out. So it'll become 2 now on this whole line. Now, what about this thing then? 5?
5, sir.
Very good. What about this?
9.
Very good. What about this?
14.
Perfect. So this will be also 14.
Yes, sir.
No, because it is coming from these junctions. So can you tell me what about this thing then? Think. Can you tell that this is also 9 because there is no such joining, because this is, we cannot go up. So this will not change, this
Yes,
will
sir.
become 9. And this will become 23.
23.
And if since this is vertically there is no connection, so this is again getting, what is the number of ways to reach B?
23, sir.
Yes. Now your question for you, how this 23 is connected to the previous question 23. There also we got the total number of cases is 23. Yes or no? Yes.
Yes, sir.
And what is 6 and 4 indicating?
Number of successes and failures.
Yes. So what is the number of failure we have? 6.
6 and 4 successes.
4 successes. So we have actually taken 10 attempts in the grid. So can you connect? How is possible?
Total number of steps in any path will be 10, sir.
Very good. Total number of the steps is 10.
10.
Exactly. Very good. Exactly. Perfect. Means whatever path you are taking, you are taking 6 unit right and 4 unit up by any chance. Correct or not?
Yes, sir.
Yes. And why this line, the diagonal I drew, what is the significance of that diagonal? Why I drew the diagonal? This is actually I drew like this. In fact, suppose I can draw 4 by 6 also, means 4 on the horizontal and 6 on the vertical.
6 on
Okay? So that is also going to the same thing, correct?
Yes, sir.
Yes. So in that case, what is this significance actually? What we are taking? That is perfect that in every path we are taking the 10 attempts. In every whatever path we are choosing, 10 attempts. So basically what we are doing, we are actually finding the number of paths from 00 to 64.
Yes, sir.
No?
Yes, sir.
Yes. 00 to 64. I think here one thing I did mistake. The slope of the line I have taken wrong. You see? 4 by 6 now I have taken 3 by 4. I was thinking 4 by 6 in the grid in my mind, but it draws 6 by 4. So this will become 2 by 3 na?
Yes, sir.
Yes. But anyway, that is correct graph. Because we drew like that and we just horizontally draw this by the perfectness with the grid, that's automatically came up. Otherwise, if you draw manually and in some other cases, that will be a difficult situation. Okay, so what I wanted to convey that we are going from 00 to 6,4.
6.
We are always
Yes,
below that line. So we are finding this path. So what we are making actually, so whenever success is happening, it is happening with which step? Can you tell me? With what step you can say? Suppose you are taking some steps. So which step the success is represented by?
upward, sir.
Upward. Correct?
Yes, sir.
And what step your failure is actually represented by?
Right, sir.
Exactly. So that is why we are going below, means leaving below, or because whenever we are moving up, there will be success. So basically we are finding that number of ways to reach at 6,4, and the path means how many such ups and right we will take to get the 6-4 combination. So it turned into the same kind of situation that what are the number of ways to starting from one corner to go to the next corner, but we have to be always below the diagonal.
Yes.
Why? Because if you go beyond the diagonal, what will happen? The number of successes, number of failure will change also. That we don't require, na?
Yes, sir.
Correct?
Yes, sir.
Yes. So that is the question I wanted to discuss with you, because I knew that you can, your probability and your this kind of combination questions thinking skill is very powerful, and I knew that you can, means together we can do it. Very good.